In our second tutorial, we will find all rational roots for a polynomial function. So let's flip over to this, the fundamental theorem of algebra. Now, we're not going to go into the actual definition. I'm just going to give the simplified version. Basically, what this means is the degree. That's really what we're interested in. The degree will tell how many solutions exist. We're really interested in what the degree is because that'll basically tell us how many solutions our function has. The fundamental theorem of algebra can get involved, but that's basically what we're talking about. So when we're talking about how many solutions, now this direction uses the word solutions. There are 4 words that we could use for solutions: zeros, roots, x-intercepts, or solutions. How many solutions do the following equations have? Well, this is why we set our equations equal to 0, because we're looking for our zeros, our answers. The degree of this is 4. That's the highest degree that I see. So there are 4 solutions. Or there are 4 roots. Or there are 4 zeros. Now I cannot technically say that there are 4 x-intercepts because maybe they're not going to be real answers. We're going to find out in a later tutorial that we can find imaginary solutions, but I do know that there will be 4. So I'm not going to put 4 x-intercepts because until I know something more about that function, I don't know if it's going to cross the x-axis. So if we call it f of x, I'm looking at the degree here, 7. Okay, great. That means that there are 7 solutions. It's really that simple. You look at the degree, and that will tell you how many solutions there will be. How many are real and how many are imaginary, we need to do some more math before we do that, before we can answer that. Okay, so let's look at our examples 5 and 6. We're going to be using the rational roots theorem, the fundamental theorem of algebra, and synthetic division to find all of the roots of our polynomial. So first, let's start with our p and q. We'll call our constant p, we'll call our leading coefficient q, and let's look at our possibilities. We'll do p over q right here. So all the factors of 20, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. I like to go up in an order. And thankfully, I'm only dividing by plus or minus 1. So all of the possibilities are right here in the numerator. There are 1, 2, 3, 4, 5, 6. There are 12 possibilities. So if I'm looking for all of our actual roots, I'm looking at the degree. I know that there will be 3. And if they are rational, then it has to be one of these 3 of these 12 numbers. So here's what I'm going to do. I'm going to set up a synthetic division. I know that I'm going to be dividing into the coefficients that I see in my polynomial. So let me put those. I've got 1, 5, -4, and -20. What I don't know is which number to put right here. It's going to be one of these 12 numbers, so really it's just a guessing game right now. So maybe just watch me for a little bit until we find one that works. Let's just go in order. Let's try positive 1. Let's put a 1 in here and see if it works. I'm going to drop this 1 down past the line. I multiply, I add, I multiply, I add, I multiply, and I can see that this is not going to cancel out to 0, so I know that 1 is not a possibility. Let's erase. And I think that it would be wise for us to cross out positive 1. Now, maybe negative 1 works. Let's go to 2. Let's see if 2 works. Plug in a 2, and let's drop the 1 down. 2 times 1 is 2. Add it up, 7. 2 times 7 is 14. Add it up, 10. Hey, look at that. I see it. 2 times 10 is 20. Add it up. I know that I get my 0. Once I get my 0, I know that I have one of my roots, one of my solutions. So 2 works. Yay. Now I could keep going and keep trying other numbers until I get the other 2 numbers, but I think there's a a more logical way to go. Once we've depressed this 1, this x cubed past the line, this refers to 1x squared. And therefore, this would be a positive 7x, and this would be a positive 10. This is a quadratic. We should know how to factor any quadratic. And if we can find the other two factors, then we can easily find the other two roots. So let's factor. I think that's a whole lot faster than having to guess and check, from 10 other numbers. So x times x, that's the only option for x squared. I know it's 1 times 10 and 2 times 5. I'm just factoring here. I'll do my trial and error. I know that it will factor into a set of binomials, so I've got the x's in the front. I know the 2 and the 5 are going to get me the 7, so I'll put the 2 and the 5. And I know that they have to be the same sign, and therefore they're both going to be pluses. So these are the other two factors, and I can see that this factor will lead me to a root of negative 2. This factor will lead me to a root of negative 5. And I already found this root, which was positive 2. Don't forget about that one. So these are all of our actual answers. And if you notice, plus or minus 2 is right here, and negative 5 is right here. So these possible answers were correct. So that's what we're going to do. We're going to list our possibilities. We're going to test and test and test and test. And unless you're a very unlucky guesser, it might take a while until we get one of them that yields a 0. Once we have that, we can take the quadratic that's left and factor. Let's try it again. Let's take our P and our Q. And let's see what we got here. Let's do the P over Q first. 6 is not too bad. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, there's only 8 possibilities. Thankfully, again, it's only over plus or minus 1, so it's all 8 of these possibilities here. At least it's not 12 anymore. And I'm just going to start guessing. I'm going to put my synthetic division down. And I know my coefficients. I've got a 1, and then a negative 2, and then a negative 5, and then a 6. So 1, negative 2, negative 5, and then a 6. The question is, what are we going to guess first? You want to just go in order again? Yeah, sure, why not? Let's plug in a 1. Again, maybe you just watch me. Let's drop this 1, and otherwise you're going to be erasing with me. 1 times 1 is 1, add it up. 1 times negative 1 is negative 1, add it up. 1 times negative 6 is, oh, look at that, never mind. I got it in the first one. That's very nice. It's nice that I got it right in the first one. You're not always going to get that lucky and get it in the first try, but hopefully it doesn't take you too long. Try until you get to your 0. And now I'm going to this was 1x cubed, now this is 1x squared, and this is a negative 1x, and this is a negative 6. And there's my trinomial, and I'll go ahead and factor that. This is just a simple trinomial, x times x. I'll do 1 times 6 and 2 times 3, but I already know which one it's going to be. I'll put the x's in the front. I know that I need to get a 1 or negative 1 here in the middle, so the 2 and the 3 will be what I want to try. I know they need to alternate different signs, and it has to be a negative 1. So a negative 3 with a positive 2, that'll work. You can do a quick mental check, but we should have factored plenty by now that's not too bad. So x plus 2 is the factor. That means negative 2 would be the root. X minus 3 is the factor. That means that positive 3 is the root. And again, don't forget about the original one that we found, which was 1. I'll put all 3 of these in a nice box, and I have it. So that's what we'll do. Thanks for watching this tutorial on how to find all rational roots.